right, this is Chapter 4 from Main Q's Principles of Microeconomics. We're talking about the market forces of supply and demand. All right, in this chapter we're talking about competitive markets. We'll talk about the behavior of buyers and the behavior of sellers separately, and how we can use graphs and a model that represents the behavior of buyers and sellers to predict and talk about prices and quantities sold of a particular product or service. All right, we've mentioned before that a market is a group of buyers and sellers. Okay, how many of y'all did not get to buy or sell or anything? Okay, you were still part of the market though. You were still interacting, and even though you didn't get to participate and engage in a transaction yet, maybe you would have if we had more time. But a competitive market is a group of many buyers and many sellers. Now, when I passed out the pieces of paper, I may have messed up for a couple of people, but I tried to do buyer, seller, so it was an equal number for each one. Okay, what if I gave Brandon one piece of paper that said seller and the rest of us were buyers? What could have Brandon done to the price? He would have had a lot of control over the price, right? We would have seen an equilibrium price much higher than $10.25. Or if I had Maggie as the only buyer and we were all trying to sell to her, what do you think would have happened to the equilibrium price? Okay, much lower than $10.25. She would definitely have the pick of who she wanted to sell to. So with a competitive market, we have many buyers and many sellers, and we're going to learn about different market structures for that. It's not the case, but keep that in mind for this chapter. Okay, also I told you to assume that each truck was exactly the same. We had a homogeneous, standardized product, and keep that in mind too. We have so many of us that no one has a lot of control over the price, and so you can say that each one of us was a price taker. Okay, buyers, we're going to talk about your behavior first. Okay, quantity demanded is the term that we use just to talk about how many total trucks you all as a group were willing to buy. And your behavior demonstrated the law of demand. Okay, how many of you all, and raise your hands when you fit this category, how many of you all were willing and able to buy a truck at $11? How many of you were willing and able to buy at $11? Had enough money? Okay. $10.90. I see one hand. $10.80. Keep your hands up. $10.70. $10.60. $10.50. $10.40. $10.30. $10.20. Okay. $10. More and more hands are going up. As I started at 11, right, going down to 10. Inverse relationship, right, between price and quantity, and that represents the law of demand. The quantity of a good falls when the price rises. All right, a schedule is just a table of data. It's a table of our price and quantity data. And we'll notice here that Helen's preferences obey the law of demand. We've got prices going from 0 to 6, so that's increasing. And then if it's an inverse relationship, then the opposite's happening with quantity. And we see that happening here with a decrease in quantity. Now we use our data from the demand schedule to plot all of these points for the demand curve. And if you connect all the dots there, oops. We call it a curve, and when you use real data in real life, it may have kind of a curved shape like that. But in this class, with the principles levels class, it's perfectly fine to have a straight line. As long as you have something that is downward sloping to the right, then representing an inverse or negative relationship between price and quantity, that's perfectly fine in this class. I know it's a curve, but it's called a curve, but a straight line is perfectly fine. Remember, this is price per unit. So how do we read this graph? This is price per latte. It's $6 for one cup of coffee. And what does that mean? How many lattes are going to be sold at $6 a piece?
4.
Okay, a total of, this is total right here, total of 4 lattes are going to be sold at $6 a piece. At $5 a piece, a total of 6 will be sold. That's how you read these graphs. All right, the difference between individual demand and market demand. Remember yesterday we were talking about Subway sandwiches. I could ask an individual. I could have said, DeMarcus, how many sandwiches would you buy at $20? How many sandwiches would you buy at 10? How many would you buy at 5? They were 5 apiece. So that I could graph his responses within a demand curve. There would probably be an inverse relationship. Would you say you would buy more when they're cheaper, DeMarcus? Okay. If I went around to every single person in here, assuming that y'all represented the market for Subway sandwiches, and said $20, how many would you buy? How many would you buy? How many would you buy? And tallied up all of those responses, then I would get the market demand at that price. And so with market demand, we've just tallied up the answers for everybody in the market in terms of how many products they would buy at each price. So individual demand, we've just asked one person. Market demand, we've added up all the responses, all the buyers at each price. You can see that these numbers are larger here because we've included those 2 people in the example in the book, I think Helen and Ken. But the law of demand still holds. We still see this inverse relationship. It still has the same shape as individual demand. Okay, your author points out to absolutely know the difference between a change in quantity demanded. Remember that phrase, ceteris paribus, means other things equal. We're pretending that everything's staying the same. When we're moving along the line, that's called a change in quantity demanded. So don't get that mixed up with a change in demand where the whole demand curve actually shifts. I'm going to go backwards one slide. Moving from this point to this point, what do we call that? Change in quantity demanded, because we're moving from 12 lattes being sold to 15 lattes being sold. When the price of one latte changes from $4 each to $3 each. That's a change in quantity demand, right? So what is this one? A change in demand? It's when the whole thing shifts out to the right. That more people want these lattes at every price. Before, it was $4 to $3. It was on sale for $1 and $1 cheaper, and that's why people were buying more. Here, at every price, people want more. And there are several things that can cause a change in demand. The first one is the number of buyers. You all know that a lot of the Baylor students leave Waco during the summertime, and it's kind of nice when you're going out to eat. The lines are a little shorter when they come back in the fall. You might expect to wait a little bit longer at Cheddar's, at Nefa's, because more people are here. It's not because Cheddar's and Nefa's have lowered their prices and it's cheaper. It's just we have more people, and that is an example of something that can increase demand and shift the whole thing out to the right. The second thing that can shift demand is income. All right, know what a normal good is. A normal good, the definition of it is when you have more money, you buy more of it. So when you have more money, the demand curve for that product will shift out to the right. Anyone think of an example? What if you won the lottery, what are some things that you would buy more of?
High quality clothing, I go to Dillard's more.
Okay, luxury car. Let's say brand name product. Okay, most products are normal goods, but we have something called an inferior good. Okay, that means the demand for that is negatively related to income. When you have more money, you buy less of this.
Yeah, I was about to say that.
Okay, ramen noodles. We're not going to buy as much. We have more money.
Redbox, because you go to the movies, you can afford to go.
Okay,
Yeah.
Redbox movies. Okay, those are some great examples. But know the definition and then also know what it's going to look like on a graph. So when you have more money, you're buying less ramen noodles. Which way is the demand curve for ramen noodles going to shift? To the left. Okay, number 3, the third thing that can shift demand either to the right or to the left are prices of related products, prices of related goods. All right, let's talk about substitutes. These are things that you can switch out just like the name is called, but the definition of it is if an increase in the price of one causes an increase in the demand for the other. That means if one's getting super expensive, you're not willing to pay for that product and you're going to switch to something else. Okay, anyone think of an example?
Gatorade raising in price, you switch to Powerade.
Aha, Gatorade and Powerade. Can you think of another example?
Dr. Pepper, Dr. Thunder,
Okay.
Dr. Top, whatever.
Dr. Cheapo.
Dr. Pepper and Dr. Thunder. If there's an example on the exam about, Gatorade and Powerade, for example, you can't say, I'm not going to answer this question, there's not a right answer because I don't drink either one. That's not the definition of what a substitute product is, right? You've got to be thinking either substitutes or complements. If the price of one goes up, would most people shift to that one, even if you yourself don't drink sports drinks? Or you yourself don't drink soft drinks. Okay, complementary goods. An increase in the price of one leads to a fall in demand for the other one. So these are things that you usually consume together. So when one gets super expensive and you're not willing to buy it, you're not going to be buying as much of the other one as well because you usually consume them together. Does anyone think of an example?
I got it.
Chips and dip. Okay?
Whiskey and Coke.
Peanut butter and jelly.
Good. All right. Put that back up here. So y'all can see. Okay, so y'all get the idea. So now, fall in demand, which way is this going to shift? Left, to the left. And an increase in demand, that's going to be represented by a shift to the right. Okay, consumer tastes is the fourth thing that can shift the demand curve. For example, the Atkins diet. Do y'all remember people who were on that? Oh gosh, we've had several diets. South Beach diet, people are not eating as many carbs. Okay, so if they're trying to eat more protein and eggs, the demand for eggs would shift to the right. The demand for donuts would shift to the left. And we're talking at every price. You'll remember we had a Krispy Kreme here in town, and several, and not just here, it's not just here that they closed down, but they had closed down several stores across the nation. And they interviewed in the Wall Street Journal, they said one of the factors in that decision to close down a bunch of stores because of the Atkins diet, because that was so popular. fifth thing that can shift demand either to the right or to the left is expectations. So if we expect gas to be super expensive tomorrow, we might all go and try to fill up our gas tanks today. Or if we're all expecting to get raises, then we may go out and buy new houses, new cars, not just, or we might be really optimistic about the future, and then the demand for those products may increase. And so this is just a summary slide. This is table 1 on page 71 in your book. These 5 things can actually shift demand either to the right or to the left. Price is the only thing that can cause a movement along the curve. Everybody's in good shape so far? Okay, sellers, we're going to talk about you now. Oh, there's the 5th thing down there. Sorry, expectations. All right, the total amount of, in our case, trucks, whatever product that we're talking about that we're willing and able to sell is the quantity supplied. Okay, so sellers. See a show of hands. How many of y'all were willing and able to sell your truck for $10? Okay, a couple hands. Keep your hands up. 10, 20, 10, 30, 10, 40, 10, 50, 10, 60, 10, 70, 10, 80. Okay, more and more hands are going up as the price is going up. That represents the law of supply. There's a positive or direct relationship between price and quantity. Now, as consumers, we like lower prices, but sellers, you would have been happy to take $11 for your product. You would have been happy to take $20 for your product. You would have been even happier to take $50 for your product, right? It's more profit for you. That's more money for you to put into your production process and maybe improve it to make more. So there's a direct relationship here with the law of supply. So again, just like we did for demand, we're using these data points in our schedule, supply schedule, to create a supply curve. You just plot all those little points, 0, 0, 1, and 3, for example. So here's $1 and a total of 3 are being sold. Again, remember, this is price per unit. So if a coffee is $2, how many total coffees are going to be sold? Cups of coffee? 6. Yeah. So if they're $3 each, a total of 9 will be sold. So this is per unit over here. This is total over here on the quantity axis. This is just like what we were talking about with demand. Market supply, that means that we have surveyed a bunch of different sellers, not just one company, but a bunch of different sellers of that product. And we can build a market supply curve, but it's still going to look the same. It's going to be upward sloping to the right. Now, there are some things that can shift supply, just like some things that can shift demand. Remember, if there's a change in the price of the product itself, it's going to move along the curve, and we call that a change in quantity supplied. But if it's something other, a determinant is a fancy word for something that's going to shift supply or demand. That is called a change in supply. We'll go through each one of these. It kind of lightens as I go to the next one. Okay, these are things that can shift supply either to the right or to the left. Number 1, input prices. All right, if you're an ice cream maker and there's a sugar shortage, sugar is one of your inputs, right? So all else equal, are you going to be able to make, assuming that your budget stays the same for your supplies and you can't spend any more on it, if there's a sugar shortage, one of your inputs and ingredients is more expensive, are you going to be able to make more or less? Okay, so your supply curve is going to shift to the left. What if you have better technology?
Make more.
Able to make more. Okay, what if you are expecting a really, really hot summer? Then you'll increase production, right? That'll be a rightward shift. And the number of sellers, if we've got, you can think of way back when, I don't even know if they're still around, Baskin Robbins.
Okay. There's one.
Oh, no. I mean TCBY. Do you remember around Sanger? We used to have a TCBY in, now, what other places do we have for frozen yogurt? They're not even around, but U-Swirl, okay, Oso's, lots of other places that you can get frozen yogurt now. So when the number of sellers increases, that can shift supply to the right. Okay, supply is upward sloping to the right. Remember, zeros down here, price and quantity are always your vertical and horizontal axes. When supply increases, it's going to shift away from zero. So that'll be your new supply curve. Like if we had better technology, that would happen. If you had unfavorable expectations about the future, maybe people, if you're Krispy Kreme and you know that people are going on Atkins diet, you would make less. I know in everyday language we say supply is going to go up or down, demand is going to go up or down. Just change your way of thinking. I know you mean increase and decrease, but don't try to shift supply up and down like that. Students get really mixed up when they do that. So when you say that supply is going up, think, okay, that means an increase, that means a rightward shift. We're going away from zero. When supply is going down, just think to yourself, okay, I really mean that it's a decrease and that's going to be a leftward shift. So think of horizontal shifts.
So supply only shifts right or left.
And then same for demand. Only right and left. Another thing I wanted to point out. Remember when we were talking about production possibilities in Chapter 2? We had two products on each of the axes. Remember Starburst and Snickers. We were talking about the production of two products. Here we're talking about supply and demand. We're talking about the price and quantity of one product. So in this case, we're talking about ice cream. If we had donuts, it gets its own graph on supply and demand, with supply and demand as the axes. If we're talking about Coke, it gets its own graph. If we're talking about peanut butter and jelly, each product gets its own supply and demand graph. All right. This is Table 2 on page 76 in your book, and that just summarizes what can shift supply. These four things here, and remember that a change in the price of the product itself just causes a movement along the supply curve. All right, now we're going to put these two curves together. Price and quantity are always on your axes. Supply goes up, demand goes down. I remember when I first took took economics for the first time, it was really hard for me to just remember where everything, all my labels went. So if this helps you, just draw your axes like this. Remember, price goes here, quantity goes here. Just draw a big X in the middle. And I came up with a little saying, please, skip that one, Sally, don't quit. You've got to label all of these correctly, because if you get supply and demand mixed up, you're going to miss every question that I asked you about the new equilibrium. So make sure that you know how to label this. This is price, quantity, supply, and demand. Remember, demand goes down, it starts with a D. supply has that word up in there, it slopes upward to the right. So those are some little things that can help you remember how to draw that. All right, equilibrium. It's right where they meet. You identified equilibrium already with our equilibrium price of 10.25. Here, our equilibrium price is $3, and equilibrium quantity is 15. So when I ask you to identify equilibrium, it's just right where they cross. And then if I asked you about equilibrium price, you just go straight out to the price axis. If I asked you about equilibrium quantity, you just go straight down to the quantity axis. Okay, your author gives you some hints here when you're analyzing what happens at the new equilibrium. We just talked about all these things that shifts demand and supply, so we're going to apply that to this graph that we just had up on the previous slide. Okay, you're going to have a scenario and you have to decide, is it going to shift supply or demand? If we're talking about consumer income, consumer expectations, the price of another good, is that supply or demand? Okay, consumer income, expectations about the future, consumer expectations, prices of related products. All of that stuff we talked about with demand. So you should think in your mind, okay, that's demand that's going to shift to the right or to the left. If in your problem you read about technology changing, or the number of sellers increasing or decreasing, you should think that's supply changing. So that's what he's talking about with number 1. Decide whether the impact is going to be on supply or demand. Think about, is it a good thing or a bad thing? Are we going to have more demand or less demand? More supply or less supply? And then you can find the new equilibrium. Okay. Always start out with price, quantity, supply, and demand. Okay. It says, show how an increase in demand can affect the equilibrium. Okay, let's say that it's going to be really hot. People are wanting more ice cream because it's summertime and it's 100 degrees outside. Demand's going to shift to the right. So we've got the red line here. Where's the new equilibrium? Here's the old one, where the two blue lines met. The new equilibrium is going to be right here. Okay, before I click through and it shows you, at the new equilibrium, what happens to the price? It's increased. How do you know? Here's the old equilibrium. It was $2. At the new equilibrium, remember I said if I ask you about equilibrium price, you find where they crossed and you go straight across to the price axis. Zero's down here, so it's got to have gone up. Okay, going back to our new equilibrium. What's happened to the new equilibrium quantity? It's gone up because here's our old one at 7. Okay, you find your new equilibrium. If I ask you about the new equilibrium quantity, you go straight down. Here's 0. This is going to be 10 or something like that, right? So what can we say here? When hot weather increases the demand for ice cream, it's going to shift the demand for ice cream out to the right. And more ice cream cones will be sold at higher prices each. That's what we can say about figure 10. Now let's take a look at an example of a decrease in supply. Again, I can't emphasize this enough. Make sure that you've got this set up, supply, demand, price, and quantity, and have everything labeled correctly. How a decrease in supply affects the equilibrium. Okay, there's a sugar shortage. Ice cream makers can't make as much ice cream as before. That's going to shift supply to the left. Okay, there's the red line. And it's perfectly fine to label S1, S2. You can write it out, supply 1, supply 2 for me on your homework that I'll give you in a second. Okay, so here's the initial equilibrium. At $2 each, 7 ice cream cones are going to be sold. All right, before I click through and it shows you, at the new equilibrium, that's where the new supply curve hits the old demand curve. What's going to happen to prices? That's going to be an increase, right? Because you find where they meet and you go straight out to the price axis, since that's what I asked you about. What about quantity? Okay, you find where they meet, you go straight down to the quantity axis. Here's 0. I'm getting close to 0, so it had to have decreased. And if I click through, what does this mean? What can we say about this figure now? When there's a sugar shortage and ice cream suppliers aren't making as many, they're not as willing and able to make as many ice cream as before at every price, fewer ice cream cones are going to be sold at higher prices each. All right. We're going to come back to example 3. At the end of this chapter, there's a double shift where supply and demand can both move. But we'll talk about this after the quiz next time. So we're gonna save these few slides for next time. Do you want to talk about these last slides though? Actually, because of time, I think we're going to save all the rest of the slides in this chapter for next time. So this is just the first part of chapter 4, and we'll go ahead and stop.